In this video, we're going to look at the examples in the section 2-3 slides. Starting here on page 3, we are first asked to add a couple of fractions and then answer a question about a plumber and what size hole must be bored to install the insulated pipe. So let's start here. We're going to find these sums. 3/8 plus 1/8 we can just add across because we have the same denominators. So 3 plus 1 is 4 over 8, and we know that that simplifies. If we divide 4 by 4 and 8 by 4, we get 1 over 2, or 1/2. Here it's a little more complicated because we have three different denominators. But the handy thing is that 16 and 32 are all multiples of 8. So if we take 5 over 32, that can stay as it is. 3 over 16, we'll multiply this by 2 over 2 to get a denominator of 32, and 7 over 8, we multiply that by 4 over 4 to get our denominator. So that's 5 over 32 plus 6 over 32 plus 28 over 32, which gives us, let's see, that's going to be 11 plus 28 is 39 over 32, or 1 and 7/32. Our next problem, we're given this. A plumber uses a 9/16 inch diameter copper pipe wrapped with 5/8 inch insulation. We need to know what size hole must be bored in the stud to install the insulated pipe. To do that, we take the diameter of our pipe, 9/16, plus, and then we've got 5/8 inch insulation. But here's the important thing. We wrap that insulation all the way around the pipe, which means we've got an extra 5/8 on either side. We're going to add that twice. Now, 5/8 is the same as 10/16. So this is 9/16 plus 10/16 plus 10/16, which is 29/16, or 1 inch, or 1 and 13/16 inches. Moving on. There we go. Our next problem is fairly simple. We're asked to add some mixed numbers. So let's take a look at the process for adding mixed numbers. First, we add the whole number parts, then we add the fractional parts and reduce to lowest terms, then change the improper fractions to whole or mixed numbers, and then add the whole number parts. So here's what we get. We're going to rewrite this as 5 plus 2/3 plus 7 plus 3/8 plus 4 plus 1/2. Now, we take 5 plus 7 plus 4. 5 plus 7 is 12, plus 4 is 16, plus 2/3 plus 3/8 plus 1/2. Now we want to find the least common denominator here, and that's going to be 24. So we want to write these all as over a denominator of 24. So that's 16 plus, well, 3 times 8 is 24. So we multiply 2 by 8 to get 16 over 24. 8 times 3 is 24, so we multiply 3 by 3 to get 9 over 24. And 2 times 12 is 24, so we multiply both numerator and denominator by 12 to get 12 over 24. We add our fractions. 16 plus 9 is 25, plus 12 is 37 over 24, which is 16 plus 1 plus 37 minus 24 is 13 over 24. So this comes to 17 and 13/24. Moving on again. I just realized that I didn't stop this. I'm so sorry. Okay, so here is what I did. I took our original mixed numbers and separated them into whole number parts and fraction parts. 5 plus 2/3, 7 plus 3/8, 4 plus 1/2. Then I added up all of my whole number parts. 5 plus 7 plus 4 is 16. My fraction parts are still there. I change my fractions so that they have the same denominator. Then I added up those fractions, changed it to a mixed number, and added the whole part of the mixed number to my original 16. Okay, now moving on. Next, we've got a subtraction problem. We want to subtract 7/32 from 3/8. Well, that's not too bad because 8 times 4 is 32, so we just multiply the numerator and denominator by 4. 12 over 32 minus 7 over 32 is 5 over 32. Nice simple one. And yet again, the lights go off, so I have to do my dance of the lights. You can stare at that while I get the lights back on. There we go. That didn't take long this time. The dance of the lights can be a long thing or a short one. Okay, moving on. We've got a whole bunch of these problems, and this is actually the last slide. These are just a bunch of examples about working with subtraction and mixed numbers. So let's take a look. So for these first three, we're just doing some simple subtraction. 5 7/8 minus 4 1/2. Okay, so first we write this as 15 plus 7/8 minus 4 minus 1/2. Combine the whole parts. 15 minus 4 is 11. Plus 7/8 is, we can work with that, and then we can change this to eighths. That's minus 4/8, which gives us 11 plus 3/8 is 11 3/8. Next, 18 1/2 minus 15 3/4. This is a little more complicated, and that's because 3/4 is bigger than 1/2. So instead of, I'm going to break this up again, but I'm going to change it a little bit. So I've got my 18 plus, I'm going to take 1 away from the 18 and make it a 17. 17 plus 1/2 plus 1 is the same as 3/2. Minus 15 minus 3/4. Okay, so now 17 minus 15 is 2, plus 3/2 is 6/4 minus 3/4. Gives us 2, 6/4 minus 3/4 is 3/4. Finally, we've got 45 1/3 minus 27. We don't have to worry about the third here. We just subtract the 27 from 45. I mean, we can rewrite this as 45 plus 1/3 minus 27. 45 minus 27 is 18, plus 1/3 is 18 1/3. Next up, 127 1/2 pounds of sugar is used from an inventory of 433 3/8 pounds. How many pounds of sugar remain in inventory? Okay, well, this becomes 433 3/8 minus 127 1/2. Okay, so I'm going to break it up, but again, since 3/8 is less than 1/2, I'm going to take a whole and add it to my eighths. That's 432 plus 3/8 plus 1 is going to be 3 plus 11/8 minus 127 minus, we'll turn this half into eighths, that's 4/8. Okay, so then we get 432 minus 127 is 305, and 11/8 minus 4/8 is 7/8. 305 and 7/8 pounds of sugar remaining in inventory. How many feet of coaxial cable are left on a 100-foot roll if 27 3/4 feet are used from the roll? I start by taking my 100, and I'm going to minus 27 3/4. Sorry, I'm recording a video for another class. And now I'm going to write this as 99 4/4 minus 27 3/4. 99 minus 27 is pretty simple. That's 72. 4/4 minus 3/4 is 1/4. And there we go. 72 1/4 feet remain. All right, next. Now we're going to do some addition and some subtraction, and we've got some complicated fractions here in that none of them have the same denominator. So this is 5 plus 2/3 plus 1 plus 1/2 minus 3 minus 2/5. Okay, so 5 plus 1 minus 3. 5 plus 1 is 6, minus 3 is 3. No problem there. Now we need to get the least common denominator of 3, 2, and 5, and that is 30. So we've got plus 20 over 30 plus 15 over 30 minus 2/5 is 12 over 30. Okay, so 20 plus 15 is 35, minus 12 is 23. That gives us 3 23/30. Last problem. Three lengths measuring 5 1/4 inches, 7 3/8 inches, and 6 1/2 inches are cut from a 64-inch bar of angle iron. If 3/16 inches is wasted on each cut, how many inches of angle iron remain? Okay, so we've got 64 inches of angle iron. We're going to take away from that 5 1/4 plus 7 3/8 plus 6 1/2 plus we've got to make 3 cuts. So that's 3 times 3/16. Okay, so that makes 64 minus, I'm going to add up my angles, my whole numbers here. 5 plus 7 is 12, plus 6 is 18, plus 1/4, plus 3/8, plus 1/2, plus 9/16. Happily, 2, 4, and 8 are all factors of 16, so this will be pretty easy to add up all of those. We just need to change our bases. 64 minus 18 plus 1/4 is 4/16 plus 3/8 is 6/16 plus 1/2 is 8/16 plus 9/16. Okay, so we've got our 64 minus 18 plus 4 plus 6 is 10, plus 8 is 18, plus 9 is 27/16. That's 64 minus 18 plus 1 and 11/16. Gives us 64 minus 19 and 11/16. Now we do our subtraction. We're going to rewrite this 64 as 63 plus 16/16 minus 19 minus 11/16. 63 minus 19 is one less than 16, is one more than 63 minus 20. 63 minus 20 would be 43, so 63 minus 19 is 44. 16 minus 11 is 5/16. 44 and 5/16 inches remaining. That's it for this video. If you have any questions, please get in touch.